Did you hear about the chemistry major who asked the statistics major out on a date? She failed to reject him. Now, you probably don't get it now, but at the end of this lesson, that joke is hilarious. Anyways, so we're going to be talking about hypothesis, which is a claim about the value of a population characteristic. When we're performing a significance test, we're trying to compare claims to data. So it's what you think is true about the population compared to what you actually measured for the sample that you got. Now, a null hypothesis, which is written as H naught, is the one that we initially assume is true. And we test it with data. It's like, okay, we think this is true. Let's go get some data. And if this still looks true or not, is it plausible? It should reflect the belief or suspicion before you have the data. Now, why null? It's a skeptical claim that nothing is different, that it's the same as what we thought. Think it's kind of dull. It's more interesting if we improve the other thing. So a null hypothesis is usually written in the form with this H naught, and that's your null hypothesis symbol. P naught, in this case, since we're doing proportions, that's your proportion that we're using for the null hypothesis, equals some value that we're assuming. Now, this is what we think the parameter is. This is not the statistic from the data. All right. Now, sadly, in statistics, we will never prove a null hypothesis to be true. Some of you may remember inductive reasoning from geometry, where we had patterns, and we said, oh, this pattern looks likely, we can never prove it untrue. It's kind of the same there. Now, how could we do in inductive reasoning? What could we do? We could find a counterexample. In our case, if we can show it is implausible that our null hypothesis is true based on what we saw, then we can actually reject it and propose that there is evidence to support an alternate hypothesis. So the alternate hypothesis is the one you're really seeking evidence for to say, oh, that null's not good enough, this one's better. And it's usually in one of the three forms. Either P naught is greater than your null value, it's not equal to the null value, or it's less than the null value. In this example, I've got some M&Ms, and they're supposed to be 20% orange. Now I have a bag of 122, and there's only 21 orange ones. Does this contradict the 20% claim? So first of all, let's just practice by stating our hypothesis. The hypothesis is whatever it's supposed to be, all right? So it's going to say, oh, we're going to say P equals 0.20. The true proportion of orange M&Ms is 0.20. So that's how I write it in words, all right? The alternate is it doesn't equal 0.20. It might be higher, might be lower. So let me go back. So the true proportion of orange M&Ms is not 0.20. Now let's look at this example on unfit teens. In a 2005 study, 2,205 adolescents ages 12 to 19 took a cardiovascular treadmill test. 750 had a poor level of cardiovascular fitness. Researchers believe that the sample was representative of adolescents nationwide. Does this sample provide support for the claim that more than 30% of adolescents have a poor level of cardiovascular fitness? So first of all, our null hypothesis is not about what we got on the sample, which was 750 out of 2,205. It is about this 30%. And remember, the null is usually just equal to whatever that proportion is. So our null in this case is that the proportion is 0.30. The true proportion of adolescents with a poor level of fitness is 0.30. It's good to give it context. So what's the alternate? Well, they want more than. So let's make that the alternate. P is greater than 0.30. All right. Let's go ahead and take a look at fresh coffee. People of taste are supposed to prefer fresh brewed coffee to the instant variety. On the other hand, perhaps many coffee drinkers just want their caffeine fix. A skeptic claims that only half of all coffee drinkers prefer fresh brewed coffee. Each of 50 subjects taste 2 unmarked cups of coffee and say which he or she prefers. 1 cup in each pair contains instant coffee, the other fresh brewed coffee. We find that 36 of our 50 subjects chose the fresh coffee. So what are we looking at? Our skeptic is saying, hey, it's 50-50. They can't really tell the difference. It's like they're flipping a coin and guessing. So our skeptic would say the null is P naught is 0.50. The true proportion of drinkers who prefer brewed is 0.50. In other words, that they're pretty much equal to them. And the alternate is that it's greater than 0.50. All right, so that there actually is a difference between the two. And that is our null and our alternate hypothesis for our last example.